Welcome to EDU World Space.
Problem 8.35. So we're told about this mission that NASA did where they ran a probe, shown here in red, into a comet, shown here in blue, and vastly not to scale. And we're told the masses of these things, the probe had a mass of 372 kilograms, and the comet, for this sort of thing, they only can estimate the mass, and we're told to use the lower end of the estimate, which is 0.1 times 10 to the 14th kilograms. And the probe, as it approached the comet, its speed right before impact was this 37,000 kilometers per hour with respect to the comet. So what we want to find out is what change in speed of the comet does this produce? And if the comet were to crash into the Earth, what speed would that cause, or what change in speed of the Earth would that cause? And then in both cases, we want to know whether that would be significant. And the comet is going to be moving at 40,000 miles relative to the Earth, and the Earth's mass is also given, but we'll worry about those in part B. So, for part A, we know that momentum has to be conserved, so there are no external forces acting on these. They're far out in space. Nothing can act on them externally that is going to be significant. So the initial momentum is going to be the mass of the probe times what we'll call its initial speed. And this has to be equal to the mass of the two combined things moving at the final speed of the comet, which, because we're assuming, starting off with the comet being at rest, and the reference frame we're going to be using, the final speed of the comet will be the same as the change in its speed. So this will be the mass of the probe plus mass of the comet times the final comet. And so then we just divide both sides by the combined mass. And like we just said, the final speed of the comet, because we're starting in a reference frame where we're considering everything in a reference frame where the comet is at rest, its final speed will be equal to the change in speed. And so this is equal to the ratio of the mass of the probe to the mass of the combined system of probe and comet times the initial speed of the probe. And plugging the numbers in, the initial speed of the probe is quite high, but the mass of the comet is going to be what ends up dominating the sort of value we end up getting out here, because 10 to the 14th kilograms is gigantic, 10 to the 13th, but either way. And so this works out to be 1.4 times 10 to the negative 6th kilometers per hour. So even though this is moving quite fast, its speed is 11 orders of magnitude smaller than the mass, or its mass is 11 orders of magnitude smaller than this. And so only about a millionth of a kilometer per hour is the change in speed that it produces. And even without like as a relative speed to the sort of characteristic speed we have here, this is a very small. You probably wouldn't be able to measure this very easily. So now let's assume that the comet then hits the Earth. The mass of the Earth is 5.97 times 10 to the 24th kilograms. Now notice again, the mass of the comet is about 10 to the 13th kilograms, and here we have 6-ish times 10 to the 24th. So this is again like a 11 order of magnitude difference. So we're going to probably expect a similar thing to occur where the speed change is going to be negligible. But of course we have to actually, find out if that's the case. And certainly if we want an actual number, just sort of intuitively talking about it isn't going to get us there. So nothing about the actual physical situation has changed. So we know that the change in speed of the Earth, basically we just put in the E wherever C was here, and then C wherever P was here. So the change in the Earth's speed is going to be equal to the mass of the comet plus the mass of the probe, which is negligible compared to this, but for the sake of being complete, we should include that. MC plus MP plus ME, V comet initial. And we're told the comet is going 40,000 kilometers per hour with respect to the Earth. And so plugging all of the numbers in, we find that the change in the Earth's speed is a whopping 6.7 times 10 to the negative 8th kilometers per hour, which is even quite a bit smaller than this, even though the difference in terms of the order of magnitudes of the things are similar. It still ends up being quite a lot less because that's not quite how it works out. It's just for comparison purposes. And again, this would, if this is difficult to even measure, this would also be even more difficult to measure. So this is not significant in either case. Now, of course, the actual effects of a comet this size impacting the Earth is going to be quite catastrophic, probably, because it's not the change in the Earth's speed that causes the problems. It's, the amount of energy that gets deposited into the surface of the Earth all at once. It kicks up dust and causes tidal waves and things that tend to, cause problems for living things on Earth. To the best of my knowledge, this comet didn't end up hitting the Earth, which I think we can then be grateful for, because although it wouldn't have changed how fast we're going very much, it would have been a disaster otherwise.